Today's advanced surface dressing process has its origins in the tar, spray and chip process of the last century. However, that's where the similarities cease. The modern process is significantly more sophisticated, both in execution and materials used. Plus, technical advances have been made in specialist computer-assisted plant. Today's sophisticated road dressing techniques produce a new and high-quality road surface with tightly specified chippings held in a close mosaic. This brings with it a number of benefits for the engineer and the road user. It waterproofs the surface and protects the foundation of the road. It stops any deterioration that might be taking place. It gives a textured and skid-resistant surface that plays an important role in cutting accident rates, especially in wet weather conditions and on high-speed roads. It's quick, minimizing the interference with traffic flow, and from a cosmetic angle, it can give a uniform appearance to a patched surface or even a distinctive color to a road. Constant progress means that surface dressings have now been developed for a wide spectrum of demanding circumstances. But meeting the specification precisely needs a high level of both expertise and experience. It's vital that every aspect of the complex process should be totally integrated. But meeting the specification precisely needs a high level of both expertise and experience. The role of the contractor is crucial here because the very best of them offer a total service package from initial assessment to aftercare. Contractors of this caliber are all members of the Road Surface Dressing Association, which has now merged with the Slurry Surfacing Contractors Association and the High Friction Surfacing Association to form the Road Surface Treatments Association. The RSTA was formed in 1942 with the express intention of bringing together all the parties involved and, through mutual cooperation, improving the standards of the industry. Constant, continuing endeavours for more than half a century has achieved just that. The RSDA, now the RSTA, has a major influence on British and European standards, on training, on quality, on research and development, and on codes of practice. All RSTA members are committed to quality and are accredited to Sector Scheme 13. If surface dressing is regarded as preventative maintenance and carried out by a quality-assured contractor as minor surface faults appear, then it can be highly cost-effective. But if it is left until there is considerable deterioration, then the cost of preliminary patching can be as much as, or even more than, the process itself. Surface dressing done at the right time, as shown in Road Note 39 on tables 7.3.2 and 3.3, and done in the right way, can increase the life of the road well beyond its design life. And it can be used on the whole spectrum of road types from single-track country roads with only occasional traffic to the country's busiest roads. Whatever the type of road, the dressing must be carefully designed to get the best performance out of the range of methods and materials that are now available. The way this is done is by working to the aforementioned Road Note 39 published by the Transport Research Laboratory. Its basic principle is to first choose the type of dressing, then to select the binder and specify the chipping size. As you can see, there is a chain of logical steps which will lead you to design a surface dressing to meet specific demands, whatever they may be. To demonstrate the whole process, let's look at a specific stretch of road. So, referring to Figure 8.1, the first stage is to decide whether or not to surface dress. The road here is in good shape structurally, but the surface is showing signs of deterioration. Hairline cracks have begun to appear, and in certain areas the binder has oxidized, leaving the surface porous. Definitely a candidate for surface dressing, and if it's done now, it will avoid the need for patching, resurfacing or even reconstruction. So, once the go-ahead has been given, the exact usage and condition of the road have to be determined. The first parameter is traffic volume. Medium and heavy vehicles cause more embedment of chippings than other vehicles, so they're a critical factor. Traffic volumes are analysed in terms of vehicles over 1.5 metric tons unladen per lane per day and total traffic. Speed is also important. The slower vehicles are going, the longer they are loading the surface. Once you've got your data on commercial vehicles, go to Road Note 39. Table 7.2.3, and determine the traffic category. In this particular case, we've got 550 commercial vehicles per lane with free-flowing traffic giving us traffic category D. In the absence of recent traffic flow data, then the new Roads and Street Works Act road type could be used. The more the traffic, the greater the polishing, and this causes loss of skid resistance. So consider information on accidents in which skidding was a major factor. Then consider road geometry and road layout, bends, crossings, junctions, and so on. The surface will need sufficient texture for good skid resistance at high speeds in wet conditions, and the requirements could be different for each lane. The need for skid resistance is the main factor in determining the PSV, or polished stone value, of the chippings. Now to road hardness. It's important to know the road hardness of the existing surface because it's going to be the foundation for the new surface dressing. The harder it is, the less the chippings will be embedded. The softer it is, the greater the embedment. Hardness is measured by pushing a steel probe into the road surface with a fixed force for a fixed time. The reading is given as millimeters of penetration. 10 tests should be done in the wheel tracks around half a meter apart and an average taken. Similar tests should be done at intervals where conditions change. The road temperature has to be taken at the same time. The whole test is only valid between 15 degrees and 35 degrees centigrade. There are 5 grades: very hard, hard, normal, soft and very soft. To determine the hardness category, turn to Road Note 39, Figure 7.2.1. There are 4 alternatives based on different combinations of latitude and altitude. Our site is in the south at an altitude of less than 200 meters, so we'll use category A of Figure 7.2.2. In our particular case, we've got penetration of 7 millimeters at 29 degrees. This puts us in the normal hardness grade. Now we know the traffic volumes the new surface has to cater for and the hardness of the road it is to be applied to. The next question is, what type of dressing are we going to use? There are 5 basic types, each one developed for a specific purpose. The single surface dressing. 1 application of a binder, 1 layer of chippings, the most commonly used. It's suitable for most situations, but there are limits to the stresses it can withstand. The racked-in surface dressing, developed for locations where traffic is heavier and faster. This is how it works. Binder is applied to the existing surface and a layer of chippings is spread at about 90% of the rate of a single dressing. Then another layer of smaller chippings is laid. These smaller chippings lock in with the larger ones to give a stable mosaic. The double surface dressing for existing road surfaces that are lean or as an alternative to a racked-in dressing. Essentially, it's 2 surface dressing operations with the larger chippings applied first. Because the first application of binder may have soaked into the lean surface, the second acts as a grout. The inverted double surface dressing. This is only used where there's an uneven surface, a variable surface such as a heavily patched road, or where you are dressing a minor concrete road that has not been dressed before. The pad coat with small-sized chippings goes on first to even up the surface. Then it's followed by a normal single surface dressing as before. And finally, the sandwich dressing specified for areas where the existing surface is binder-rich, something which often occurs in the wheel tracks, and unlike all other dressings, the chippings are spread first. In this case, the larger chippings first, then the binder, then the smaller chippings. 5 types, 5 different uses. To decide which one, go to Road Note 39, Figure 8.3a and Figure 8.3b. You'll notice here that there are other factors to be taken into consideration, like radius of curvature, existing surface conditions and gradient, all of which will influence the final selection. Using our data of 550 commercial vehicles per day, traffic category D and normal road hardness, we go down through the various options to get the recommendation racked in or double surface dressing with intermediate binder or single surface dressing with premium binder. We'll use a racked in dressing in this case as the preferred option. These flowcharts not only show the type of dressing but also indicate whether or not a modified binder is needed. Today, only emulsion binders are available in the United Kingdom. Emulsion binders are made up of about 70% bitumen mixed with 30% water. They can be used all through the season.